DockOn is redefining wireless with its revolutionary CPL antennas, design process and tools. In this segment, we will demonstrate the DockOn Builder application as we design a stable CPL antenna for use next to a very large metal gas meter. This is a new CPL antenna element built from the ground up and optimized with 12 parameters. We will define rules for each segment of the antenna that the optimizer will follow to define the ideal properties for this particular application. Okay, let's start with the DockOn Builder application where we create new CPL antenna element designs. To save some time, we will open up a design in progress. We select a file name and click Open. When the file loads, all the segments and structures are loaded into the Builder application. Each segment is listed in the left-hand window and a preview picture is displayed in the lower right-hand window. As you click on each segment on the left window, the picture in the lower right window will highlight the selected segment. In the upper left window are the tools for creating new segments. Other properties can be assigned to the CPL antenna design, such as the type of PCB material, the PCB margins and thickness, along with the size of the port. As you scroll through each of the segments, you can see in the upper right-hand window the logic that was automatically assigned to that segment in the D-logic coding. D-logic controls the antenna design so that each segment adheres to design rules while being optimized across all minimum to maximum values. Later, this logic will be passed on to the optimizer as it solves for the best performing antenna. On this particular CPL antenna element, we have the E-field radiator attached to the rightmost vertical segment, now highlighted in yellow. The radiator also has its own set of logic parameters for the optimizer to follow. Selecting the D-logic tab brings up a window exposing all the D-logic code behind this CPL design. This window is particularly helpful in coding unique or custom properties for a structure in the CPL element. D-logic is a .NET full-featured language created by DockOn to describe antenna structures to an optimizer application. This D-logic code is converted into a dynamic link library, which you are able to preview using the Compile Build DLL button, and then run the logic in the Builder application before it is sent to an optimizer. Selecting the Loop Builder tab brings us back to the segment editor where selecting Build will compile and run the D-logic code. Because we have CST's Microwave Studio installed and running on this computer, the D-logic code was compiled and exported to Microwave Studio automatically. Switching over to the Microwave Studio application, we can see how the D-logic has automated the import and the various parameters inside of the application. All the segments, along with their custom logic, were loaded into Microwave Studio and all tied to a DLL. The lower left-hand window shows all the segments and their parameters being loaded from the DLL. Switching over to an archive where a mechanical design has been stored, the CPL antenna element has been placed inside of the mechanical design. You can see that the CPL antenna element has been mounted on a PC board now, but the CPL segments still maintain their logic and are ready to be optimized on the PCB and inside of the mechanical design. Scrolling through each segment in the lower right-hand window, you will notice that each segment is still in place, but has been adjusted by the optimizer automatically. Let's now look at what parameters were used to make this CPL antenna element the best it could be for this integrated design. Of the 15 possible optimization parameters, the engineer selected 12 different items to set in motion. Selecting the Goals tab, you can see what goals were selected as desirable outcomes. For this particular antenna integration, the engineer wanted the return loss to be -30, the maximum gain to be at least 6 dBi, and that the efficiency of the antenna was maximized. Selecting the results for gain, we can see that the goal for gain above 6 dBi has been achieved for peak gain of 6.8 dBi and the total efficiency is -0.2142 on a goal of -0.3 dB. As the optimizer solves for the best solution, each solve is being saved into the DockOn database for use by other engineers. Searches can be organized in many ways. To locate this particular solve, we will search for a CPL antenna by application. We look for a single band antenna in the ISM band 902 to 928 MHz. The results bring back a project with a date and time the solve was completed. We click on the desired antenna and the information about that antenna is loaded in from the database into the display window. Scrolling down, we can see all the data that was generated by the optimizer for each solve and now stored in the database. The bottom of the list reveals all the data and parameters required to recreate this antenna for optimization and use in another project.